Hello guys. So in the last class we have discussed what is the limitation of deep neural network and convolutional neural network. We have also discussed the sequence learning problem. These are the problem where the output is depend on the n number of inputs, and these problem cannot be deal with the deep neural network and convolution neural network. So we are looking for a model which ensure three things. One is output yt is depend on the previous inputs. Second, the model can deal with the variable size of inputs. And third, the function which is executing in each layers is the same. So we have also discussed the value of how to calculate the value of si and yi in the last video. Now today we are going to discuss the recurrent neural network. So recurrent neural network is a network where the output is depend on the n number of previous inputs. In other words, we can say it is a network which are used to deal with the sequence learning problem. So so the RNN are mainly used for three tasks. One is sequence classification, sequence labeling, and sequence generation. In sequence classifications, we have one output for n number of inputs. For example, sentiment analysis. In sentiment analysis, the input is your sentence, which are having the number of words, and the output is whether the sentence is positive or negative. For video classifications, now in the case of video classifications, the input is a video of variable length, like 1 minute, 2 minutes, and so on, and the output it what is the activity is in video. So this is a sequence classification. That means, so we can say in sequence classifications we have only one output at the end of the models, whereas in sequence labeling we have n output for n inputs. So in other words, for single input we have a single output, like part of speech tagging that we have seen in the last class also. Third one is sequence generation. In sequence generations we have m output for n number of inputs. For example, machine translation, like when we convert the Mumbai in Hindi to English. So we have n number of word in Hindi and m number of word in Mumbai. Like Bhopal in Hindi, and Bhopal and we are going to convert Bhopal in English. So there is a different number of words in Hindi and different and English. So this problem is known as the sequence generation. So in a short way, in sequence classification we have one output for the n number of inputs. In sequence labeling we have n output for n input, and in sequence generations we have m output for n inputs. So let's discuss the previous example that we have discussed. So now this is your sequence labeling. Now in sequence labeling we have n input, 1, 2, 3, 4, 5, and the 5 output and the n output. So for each input we have one output. Right? So as I told you in the last video that the weight between input layer and hidden layer is represented by u, and the weight between hidden layer and output is represented by the v. Okay, so now the output of this layer is connected to the output of this layer. Now the output of this hidden layer is represented by the S1. Okay, so now if I want to calculate the S2 is depend on this input is multiplied by the weights u plus w multiplied by output S1 plus y is v. Okay, now the output of this layer is known as y2. So the y2 is calculated at the upper layer. In the last layer we are applying the softmax activation function, which gives the probability of n class. For example, if we have 10 classes, in the last layer we have a 10 neurons, which gives the and applying the softmax functions, which gives the probability of each class, like pronoun. What is the probability of pronoun? Our input will be a pronoun or verb or article or adjective and noun and so on. Okay, so the input y, that means input y is depend on input X, input S, the input of previous layer, weight W, weight U, weight V, YS B, and YS C. So this is a complete models, complete functions for calculating the output of each layer. So the Y1, the output of Y2 is depend on input X2, weight U2, weight W, and the output of S1 layers, fine, which is multiplied by weight V, and at the end we are getting the output of at the hidden output layers. Okay, so in the case of sequence classifications, we have only one output at the end of the models. So now suppose that so here we have a stage 1, stage 2, stage 3. So the output of stage S1 is given to the output S2. Output of S2 is given to S3, and so on. So here we have only one output, that is Y, which is depend on V, that is this weight V, the output of this layer ST plus YS. Okay, so here, so in sequence labeling we have n number of output like Y1, Y2, Y2, and whereas in sequence classification we have only one output, and the model is same for both the models, fine. So now we are going to discuss the 6 jar. These are data, task, model, learning algorithm, loss function, and evaluation. So we are going to discuss these 6 jars for the sequence classification. Then we will discuss the same 6 jars for the sequence labeling as well, fine. So as we discussed, in sequence classifications we have only one output for the n number of inputs, fine. So suppose that your task is to identify whether sentence is positive or negative. So a task is to identify the a task is a sentiment analysis, fine. So now this is a sentence. The first half was very boring. So this is a negative sentence, so the it is represented by 0, and if the sentence is positive, then it is represented by the 1. So the great performance by all the lead actors, this is a positive sentence, so the output is 1. Now, so before passing this data to the model, first we need to pre-process the data. So now here we are facing two challenges. One is all the inputs are in the form of words. As we all know that the machine can only understand number, so we need to convert this text into the number. Second, each inputs having a different size. For example, the size of this input is 1, 2, 3, 4, 5, and 6. The size of this input is 1, 2, 3, 4, 5, 6, 7, and 8. The size of this input is 1, 2, 3, 4, 5, 6, 7, and 6. Okay, so each input having this different size. So we need in pre-processing, what we need to do, we need to convert this all word into the number, and second, the size of all input must be same. Okay, so how we will convert, how we will do the pre-process. So let's start. So first we need to add the 3 words in each sentence. SOS, that stands for the start of sequence, EOS, end of sequence, and PAD is a artificial word, so, which is used to make the length of the sentence equal. So SOS is added to each sentence at the starting. SOS shows the models that your sentence is about to start, and NOS, end of sentence, is added to each sentence just after the full stop, when the sentence after the completion of sentence. So start of sentence, start of end, and then edit. So first we need to we need to count the maximum length of the word. So now the maximum length of the word is 1 2 3 4 5 6 7 और 8. ठीक, तो मैक्सिमम लेंथ कितनी है हमारी सेंटेंस की 8. So after adding SOS, start of sentence and end of sentence, the maximum length of the sentence is 10. So now we are going to convert each sentence, each input sentence of the length 10. तो जो भी हमारे पास इनपुट में सेंटेंस है, इनपुट डेटा है, उन सब की लेंथ कैसे करेंगे हम लोग, इक्वल करेंगे. तो कैसे करेंगे, सबसे पहले आपने क्या जोड़ दिया, हमने क्या जोड़ दिया, स्टार्ट ऑफ सेंटेंस. फाइन. सो क्या जोड़ दिया हमने, एंड ऑफ एस. नाउ आफ्टर द एंड ऑफ सीक्वेंस हम नंबर ऑफ पैडिंग कितने जोड़ेंगे, इट डिपेंड्स ऑन द लेंथ. सो जो हर एवरी सेंटेंस की जो लेंथ है वो कितनी हो जाएगी आपकी, 10 हो जाएगी, जस्ट आफ्टर द पैडिंग द वर्ड्स. ठीक, तो अभी नाउ till now what we did, that we convert the length of each sentence is equal, for this example suppose 10. Now the next task is to convert these word into the numbers. Fine. So first this is the algorithm for converting these word into the number. First we need to convert all word into the lowercase. Second, count the maximum number of unique words. Maximum number of unique word in your data, input data. So the word is 1 2 and 3 4 5 6 7 8 9 10 11 12 13 14. Da is already repeated, so 15 16 and so on. Suppose the number of unique words is 24 in this case, for the particular example. Now we are going to assign the unique ID for each words. तो हमने क्या किया, SOS को फर्स्ट नंबर दे दिया, the unique ID for EOS is 2, the unique ID for EOS pad is 3. उसके बाद जो फर्स्ट वर्ड है वो हमारा क्या है, दा, तो उसको हमने क्या यूनिक आईडी दे दी 4. नाउ अब आपके इनपुट में, इनपुट डेटाबेस में जहां पर भी दा आएगा उसको हम किससे रिप्लेस करेंगे, 4 से. जहां पर भी जितनी बार भी फर्स्ट आएगा उन सबको रिप्लेस किससे करेंगे हम लोग, फर्स्ट से. और जितनी बार भी हाफ आएगा उन सबको कैसे रिप्लेस करेंगे हम, 6 से. तो हमने क्या किया, पूरे डेटा को, इनपुट डेटा को हमने किस में कन्वर्ट कर दिया, हमने एक यूनिक नंबर में कन्वर्ट कर दिया. ठीक है. नाउ so as the unique the number of unique word is 24. तो अब जो भी एक नंबर है, जिस फॉर एग्जांपल इसको हमने कौन सा नंबर यूनिक वर्ड दिया, दा. तो दा को मुझे कितने, एक दा विल बी रिप्रेजेंटेड बाय द वेक्टर्स ऑफ लेंथ 24. जितने भी आपकी जो यूनिक वर्ड की लेंथ होगी वो इस वेक्टर की लेंथ होगी. यदि यूनिट वेक्टर आपके 30 हैं तो इस वेक्टर की लेंथ कितनी होगी, 30. यदि आपकी यूनिट वेक्टर 50 हैं तो इस वेक्टर की लेंथ कितनी होगी, 50. इसमें जो भी उसके करस्पॉन्डिंग जो भी वर्ड है उसकी वैल्यू 1 होगी, रेस्ट ऑफ द वैल्यू कितनी होंगी आपकी, 0 होगी. यदि मैं पर्टिकुलर इसकी बात करूं तो इसमें क्या रहेगा हमारा, केवल 1 जो रहेगा इस पोजीशन पे, 1 रहेगा, रेस्ट ऑफ द बिट्स कैसी रहेंगी आपकी, 0 रहेंगी. यदि मैं 20 इसके लिए बात करें, 24 के लिए हम बात करें, तो जितने आपके सब वर्ड कैसे रहेंगे आपके, 0 रहेंगे, केवल और केवल लास्ट में क्या आएगा आपका, 1 आएगा. सो नाउ till now, so what we did, we have converted the length of all inputs equal. Then we have also converted the each word into the numbers. Okay. So now suppose that this is your inputs, this is your input sentence, and this is your negative sentence, this is your positive sentence. So negative sentence is represented by 0 and the positive sentence is represented by 1. Okay, so it is an example of sequence classification. So we have only one output at the end of the layer. So it's had 2 neuron, one is for 0 for the negative polarity and for the positive. Okay, so now the maximum length of the word is 10th. So the maximum number of layers, maximum number of, or we can say steps, is 10. 1 2 3 4 5 6 7 8 9 or 10. तो हमारे पास जो आउटपुट आएगा वो कहाँ आएगा, 10th लेयर का आउटपुट आएगा। यदि हमारे पास मैक्सिमम जो मैक्सिमम लेंथ थी एक सेंटेंस की, यदि वो 50 होती तो हमारे पास हमारे लेयर्स कितनी होती, 50 लेयर होती, और हमारे पास जो आउटपुट आता वो कितने में आता, 50 लेयर्स में आउटपुट आता। अब सबकी लेंथ, ये इनपुट जैसे दा एसओएस किसके पास जाएगा, इस लेयर के पास जाएगा, दा इसके पास जाएगा, फर्स्ट इसके पास जाएगा, एंड ये जो हमारा पैड है, पैड किसके पास जाएगा, सबसे लास्ट लेयर के पास जाएगा। ठीक, सो आउटपुट ऑफ दिस लेयर इज डिपेंड ऑन इनपुट ऑफ दिस लेयर and input of and the output of this layer, and similarly the output of last layer is depend on the input layer, this layer, and the output of this layer is depend on this layer, the output of this layer is depend on output of this layer, the output of this layer is depend on output of this layer, and so on. So we can say the output of the last layer is depend on the output of all previous layers. Right. So now we have completed the data and task. Now two questions come in. We can have two questions at this moment. The one is, when we are adding the padding, is it will corrupt the sentence? हमने जो padding यूज किया है उससे क्या हमारी सेंटेंस की जो हमारा इनपुट सेंटेंस है उसका मीनिंग करप्ट होगा? सेकंड, यदि हम पैडिंग ऐड कर रहे हैं तो इट विल इंक्रीज द साइज ऑफ द इनपुट वेक्टर्स, तो इट विल लीड टू इंक्रीज द टाइम. इज इट ट्रू? सो वी कैन से no, there is the model will, when the model count the EOS, it will predict the outputs. So these padding is not calculated by the model. So we can say that adding is mainly used to make the input matrix is of uniform size. Computation are done only for the required number of times steps. So in this case, computation is starting from this to this only. These layers are not using for the computations of the output. Okay. The next is model. So in the as I told you that it is an example of classifications. It is a, so in sequence classifications we have the one output for the n inputs. Fine. So this weight is u. Now if I'm talking about this, the output of this layer is depend on u. This is u, input x plus ys plus w, weight of this, multiply by output of this layer plus ys of this layer, and this summation is passing to the sigmoid activation function. Then this process is continue till the last layers. In the last layers we are having the sigma softmax activation functions, which gives the probability in term probability for the each class. So here we have only two class, 0 and 1. So the so at the output we will have the probability for each class. Loss function. So now the next chart is loss function. Loss function, we are using a loss function which we have already discussed in convolution neural network and deep neural network. So the loss function is entropy loss function, which is given by these equations. We have already discussed in detail in our classes. So which is the summation of I equals to 0 to number of classes. In this case we have only two class, 0 and 1, so 0 to 1. If we have 4 class, then 0 to 4. Actual output multiply by log of predicted output. So now in this case the actual output either 1 0 or 0 1, but we are using the sigmoid activation function at this layers, at the output layers. So it will give the probability of each class in terms of, like, for example, the probability of 1 is 0.7, the probability of the probability of 0 is 0.7, the probability of 1 is 0.3. Okay, I'm repeating, the probability of 0, because it's represent the, it is a 0 or 1. So the probability of 0 is 0.7, the probability of 1 is 0.3. So if we multiply the actual output, that is 1 multiplied by log 0.7 plus 0 multiplied by log 0.3. So this terms will be 0. So the final is minus log of 0.7. Okay. So if we are interested to find the average loss of the model, so because so it is the formula for calculating the average loss is given by -1 upon n summation of log yic, where I equals to 1 to m, where I is representing for the number of training examples. So this will give the average loss for the model. Now the next chart is learning algorithm. So learning algorithm is same in this case. So the learning algorithm that we are going to discuss is gradient descent algorithm that we have already discussed, where the output, where w new is depend on w old minus eta times of delta w, where eta is a learning rate. Okay. So now here we need to learn w, u, v, b and c. Now these are the parameters. These are the parameters of the recurrent neural network that we need to learn. So initially we will define all the parameters by the 0, by some values, and then we will learn these the actual value with the help of gradient descent algorithm. Okay. So these are the model that we need to learn by using the gradient descent algorithms. Now the last is accuracy. So the accuracy is defined by the total number of actual predictions divided by the total number of predictions. Fine. So suppose that if we given the 10 input sentence and it predicts the output 8 for the correct output, so the accuracy is given by 8 divided by 10. So this is the accuracy, that is 0.8. Now these are the references where we have taken our slides video.